So this video we're going to look at what factors actually affect the rate of an enzyme reaction. Two of them we covered last year at GCSE, temperature and pH, and we're going to look at another couple along with the next video on inhibitors as well. So factors affecting the rate of a reaction. Number one then is temperature. That's quite a big one. As you know, the quicker, so if you increase the temperature, the rate of reaction increases as well. However, in enzyme reactions, this is only true up to certain temperatures, and if you go above that temperature, that rate will slow down. This is what's known as the optimum temperature. Different enzymes have different optimum temperatures. Some enzymes work best at like -10. Some, for example, in the Arctic snow flea, their enzymes work best at -10, and there are some enzymes that work best at 90 degrees, 80-90 degrees Celsius. Some thermophilic bacteria that are living on vents in the bottom of the ocean, their enzymes work best at 90 degrees. So you'll come across this graph. Obviously we've got temperature at the bottom and we've got rate at the side. So it is a curve, not a straight line. Okay, so it's geometrically curved. The rate increases because the enzyme, the substrate molecules, get more energy. So you get more energy, which equals more collisions. Okay, and that's at, let's call this, let's just draw an arrow down. So it's getting more energy, so therefore you're getting more collisions. However, okay, you get to your optimum temperature, which is here, and that is when the enzymes are working at their fastest. Past this point then, you get denaturing. The denaturing of the enzyme. That is when our hydrogen bonds will actually break. So the substrate can't bind, the enzyme is no longer catalyzed, and it's usually irreversible. So it's irreversible. This is usually around 40 degrees because that is when the temperature of hydrogen bonds, that's when the hydrogen bonds actually break at 40 degrees. But as I said before, it can be different in different organisms. So let's go over this side. Number two, we have pH. pH is very similar. pH will work. Enzymes will work at a specific pH. Usually, most of them are working around about 7 to 8. pH 7 to 8. That's in most cells. However, as you may remember from last year, you've got your proteases in the stomach. They work best at about pH 1. So again, the graph, we've got pH at the bottom, we've got rate at the side, and it's geometrically shaped. So you've got your optimum here, and let's say it's around about 7 for most enzymes. So how does it actually? What does it do to pH? So it actually affects the charge of the R groups of the amino acids at the active site. So you've got your carboxyl R groups. They're uncharged. Okay, so you got your C OOH. They're uncharged in acid pH, but they're actually negatively so in acid. So that's uncharged. But when you put them in alkali, they are negatively charged. Okay, they're alkali. So it affects these carboxyl R groups. It also affects amino R groups as well. Don't worry too much about that. Just know that it's to do with the charge. So it's to do with the charge of the R group. Okay, so next video we're looking at inhibitors and a couple of other things that will affect the rate of reaction as well.